This is my security smart lock system. It is basically a door locking mechanism which uses a keypad, an LCD display, a buzzer, and a slide switch which acts as like a backup failsafe for when connection goes down. There is a portable battery in here and an Arduino device, which is the microcontroller for all of it. This is the main device, and it also hooks up with an administration kind of control center with the Raspberry Pi, and it gives access to a kind of like an admin control where they can view who enters and when lockdowns occur, and they also have the ability to unlock and lock the door remotely. Here's an example of a working pin. So you'd have this device set up like against the wall of your door. It asks for a pin, so we have a test account, so we'll go 1, 1, 1, and 1, and it unlocks the door. So this will be hooked up to the door, and it locks it back after you after 5 seconds. It works on multiple accounts, so you have a second account set up as well with a different pin. So enter that in, and it unlocks the door, and wait 5 seconds, and it locks it again. It also has a feature where if you enter in the wrong pin multiple times, so you have 3 attempts to get it, and if you get it wrong every single time, you'll activate the lockdown mode. So here I'll go one more attempt, there's another random pin, and as you'll see, it activates the buzzer to alert people, and we also get an update in the admin control saying that a lockdown has occurred. Here is the admin control. This works from the Raspberry Pi just sitting there. Basically, you could have this set up from wherever, and we can review who is opening the door and when lockdowns happen. With this control as well, we also do have access to unlocking and locking the door. This is done through MQTT messaging, where basically upon clicking one of these buttons, it publishes a unlock or lock message to a topic. And then this Arduino is listening to that topic and picks up on it and locks or unlocks the door based on what the message is. That's how the Raspberry Pi communicates with the Arduino, and the way the Arduino communicates with the Raspberry Pi is based on these inputs. So when it locks the door, it sends a message back to confirm it, and it also tells the Raspberry Pi who is going in and out of the door. That's how we kind of have like a two-way communication between both devices. So here's an example of unlocking the door. So right now it is locked. If I click unlock, you'll see we unlock the door, and we also send it, and we also receive that it's unlocked. And then here is a lock, and we lock it back up. This kind of also acts as a fail-safe, so in case the keypad stops working, you do have another way, kind of as a like safety protocol or a fault tolerance. So you have multiple ways to access the door, that way you're not completely locked out. The other fault tolerance that I do have set up is when the whole system goes down, you still have a physical switch to unlock and lock the door as well. So with this physical switch, this is another aspect of fault tolerance in my design. So if the keypad stops working and the Wi-Fi goes down, you still will have this to work. Of course, this won't just work every single time, as that would make the whole point of the keypad necessary. So as you see right now, I am clicking the button and nothing is happening. So this only works when the Arduino detects that the Wi-Fi is not working. And then if it is not working, then it allows this to be used. To show how this works with fault tolerance, if the Wi-Fi does go down, the Arduino will realize this, and it will actually enable inputs based off the slide switch for the servo motor to unlock the door. So on offline mode, obviously the keypad might not be able to work, so it basically will only rely on like a backup switch such as this. I just wanted to mess up the Wi-Fi credential so it's unable to work. So as you can see, it's not able to connect. And if I go to actually click this, we do get a unlock. And if I go to click it again, it'll lock the door, and there you go. So yeah, that's how it works. When the Wi-Fi is able to reconnect, this will get shut off again and everything will turn back on. But yep. In terms of real world usage, this device can be used pretty much anywhere. It's fairly small and lightweight. It could be set up on a wall next to a lab room, office, security rooms, anything where you might want to check who was coming and leaving, and also you want something like a buzzer and a lockdown system in case people who you don't want going in there try to get in. The admin control also helps with this. You might have like in like a security room where you can monitor who is accessing the doors, and you could very easily create multiple of these and have it show who's accessing which door, depending on which part of the building they're in. And yeah, that's pretty much the whole project. Show one more time. And yeah.